Good morning, students. This is the ninth video of the conductance. We already in the previous video we already discussed the water, the concentration of water, number of molecules of water, number of H plus ion and OH minus ion, and also we discussed about the degree of ionization of water. Degree of ionization is 1.8 10 to the power minus 9 if we consider ratio. If you consider percentage, 1.8 10 to the power minus 7 percentage. Number of water molecules also we discussed, and ratio of number of water molecules with that of the hydrogen ion is also discussed. From this we know that water is a very weak electrolyte, because for every one molecule of H plus ion that contain 55.5 into 10 to the power 7, 55.5 into 10 to the power 7 water molecules contain only one H plus ion. That means water is very weak electrolyte. That we already know, and from this also we proved it. Today we have to discuss about the ionization constant of water. Ionization constant of water, that was the number is I. Ionization constant of water. Ionization constant of water. Ionization constant of water K, which is also called the equilibrium constant if the reaction will be in molecular form. It is in ionic form, so it is called ionization constant. Water, we know that water is dissociate, converted H plus OH minus. So this K is equal to H plus concentration, OH minus concentration divided by water concentration. Then K is equal to capital K. H plus concentration is 10 to the power minus 7. OH concentration is 10 to the power minus 7 divided by 55.5. Water concentration 55.5 mole per liter. Then your K value is equal to 10 to the power minus 14 divided by 55.5, which is nothing but 1.8 10 to the power minus 16. This is called the ionization constant of water. 1.8 10 to the power minus 16, very less ionization constant. Then next one is ionic product of water, J. Ionic product of water. Same way also we can derive water splits. It is weak, that is why it is reversible. H plus OH minus. So equilibrium ionization, it gives ions, so it is ionization constant. If it gives molecular form, then you can tell that it is equilibrium constant. Now it is H plus concentration, OH minus concentration divided by water concentration. Multiply this water with this K. K into concentration of water is equal to H plus concentration, OH minus concentration. K into water is nothing called Kw, which is called ionic product of water. H plus concentration into OH minus concentration. Then you put the value Kw is equal to H plus concentration is 10 to the power minus 7. OH concentration also 10 to the power minus 7, which is equal to 10 to the power minus 14. That means your Kw W is equal to ionization constant 10 to the power minus 14. Temperature is at 25 degrees centigrade. That means Kw means is called ionic product of water. Ionic product of water. Kw is called ionic product of water. Ionic product of water is 10 to the power minus 14 at 25 degrees centigrade. The various values, the various forms of Kw is Ijk. The various forms of Kw, we know that one form is Kw is equal to H plus concentration into OH minus concentration, that is equal to Kw. We know that water is neutral, so H plus concentration is equal to OH minus concentration, that we know. So then Kw is equal to, in place of OH I can write H plus, in place of OH I can write H plus, because H plus concentration is equal to OH minus concentration. So Kw is equal to H plus concentration into H plus concentration. So Kw is equal to H plus concentration square. Similar also, I can write Kw is equal to, in place of H plus concentration I can write OH minus concentration, because both are same. So in place of H plus concentration I write OH minus concentration. OH minus concentration, OH minus concentration, which is equal to Kw OH minus concentration square. It is one form, it is another form, and it is another form. Three forms we can write for Kw. The various forms of water, various forms of Kw means ionic product of water. Kw means ionic product of water. Ionic product of water. Okay, in three different way I can write the ionic product of water. Then how you know the relation between pH and pOH? Relation between pH and pOH. Relation is which number? IJKL. Relation between pH, relation between pH and pOH, relation between pH and pOH. We know that Kw is equal to H plus concentration into OH minus concentration. Put log on both sides. Taking log on both sides, then what we get? Now log Kw is equal to log, we can put this bracket, H plus concentration, OH minus concentration. That means log xy, log x plus log y, then log H plus concentration plus log OH minus concentration. Then what happens? Now log Kw is equal to log H plus concentration plus log OH minus concentration. Then multiply minus on both sides. Multiply minus on both sides. multiply minus on both sides, and minus log kW minus log H plus ion concentration minus log OH minus concentration. Minus log Kw is called pKw, small pKw. Minus log H plus is called pH. Minus log OH minus is called pOH. Then pKw is equal to pH plus pOH. Then what is the value of pH plus pOH? I can also know, because suppose I write minus log Kw value is 10 to the power minus 14 is equal to pH plus pOH. 14 will come to this side, minus minus plus, তাহলে 14 log 10 is equal to pH plus pOH. Log 10 1, so pH plus pOH is equal to 14. We can also find out pH plus pOH is equal to 14, but this is the relation of pKw is equal to pH plus pOH. So this is the relation. Next is, we know that Ij, K, L, M, consequently you number M. Then we know that the ionization of water is endothermic process. Ionization of water is endothermic process. Ionization of water is an endothermic process. So on increasing temperature, the degree of ionization alpha, degree of ionization also increasing temperature, the degree of ionization increases. So the concentration of H plus ion, concentration of H plus and OH minus, concentration of both H plus and OH minus also increases. Concentration of both H plus and OH minus increases. The Kw, the ionic product of water, that means Kw also increases. Ionic product of water also increases, but pH and pOH decreases. Suppose at 90 degree centigrade, the ionic product of water becomes 10 to the power minus 12. Ionic product of water is equal to, at 90 degree centigrade, ionic product of water, that means it is ionic product of water is 10 to the power minus 12. So pKw is equal to minus log Kw, that means minus log 10 to the power minus 12 plus log 10 is equal to 1. That means pKw is equal to 12 when at 90 degree centigrade. pKw is equal to 12, but pKw is equal to 14 at 25 degree centigrade, but pKw is equal to 12 at 90 degree centigrade, because the ionic product of water at 25 degree centigrade is 10 to the power minus 14. Same ionic product of water at 90 degree centigrade is 10 to the power minus 12, increases, but pKw value decreases. Similarly, at 90 degree centigrade is कौन आएगा कि कौन टांकी कौन आएगा सार at 90 degree centigrade H plus concentration is equal to 10 to the power minus 6, increases. At 25 degree centigrade 10 to the power minus 7, at 25 degree centigrade 10 to the power minus 7, but at 90 degree centigrade H plus concentration 10 to the power minus 6, and OH minus concentration is equal to 10 to the power minus 6, same at 90 degree centigrade, but at 25 degree centigrade 10 to the power minus 7, 10 to the power minus 7. So at 90 degree centigrade it increases both concentration, but pH is equal to minus log H plus ion concentration is equal to minus log 10 to the power minus 6. Minus 6 is equal to 6 log 10. 6 log 10. 6 log 10 is equal to 6. This is at 90 degree centigrade. pH is equal to 6. pH decreases, but H plus concentration increases. Similar case also we can get POH minus log OH minus concentration minus log 10 to the power minus 6 equal to 6 log 10 is equal to 6 when at 90 degree centigrade. Similarly, pH plus POH is equal to 12 instead of 14 when at 90 degree centigrade. At 90 degree centigrade, but at 25 degree centigrade it is 14. That means at 90 degree centigrade it is equal to 12. But here what is the pH of neutral water? The pH of neutral water, the pH of neutral water is 6 when at 90 degree centigrade. At 90 degree centigrade neutral water pH is equal to 6, but at 25 degree centigrade pH is equal to 7. pH is equal to 7 means it is neutral. But when you heat the water up to 90 degree centigrade, then neutral water pH is equal to 6, and pH scale is 0 to 12. But at 25 degree centigrade, the pH scale is 0 to 14. But at 90 degree centigrade, pH scale is 0 to 12, and 6 is the neutral. So neutral water pH is equal to 6 at 90 degree centigrade. That means when the temperature changes, these values are changes. H plus concentration change, OH concentration change, Kw change, pKw change, pH change, POH change, and neutral pH of water also change. Because our temperature increases, both H plus concentration and OH concentration increases. We know that 1 H plus ion is present in every 55.5 into 10 to the power 7 water molecules. But when you heat the water, more and more water molecule will convert it into H plus and OH minus equally. So both H plus and if at 90 degree centigrade 5 H plus ion is released, 5 OH minus also released. But the neutral water pH will be 6 because both the ions increases at the temperature increases. Okay, this is what happens all about that of the water. Then we will tell you next third step is calculation of solubility product of sparingly soluble salt. Calculation of solubility of sparingly soluble salt. Sparingly soluble salt. Calculation of sparingly soluble salt. So the sparingly soluble salt means the salt which is slightly soluble in water. The sparingly soluble salt, the sparingly soluble salt. ଯିବେ ନା
କ'ଣ କରୁଛନ୍ତି କି?
ଭିଡ଼ିଓ କରିଛି
କଥା ଶୁଣିବନି?
ନା ନା ଏଇଟା ଅଟୋମେଟିକ୍ ମାନେ ସେଟିଂ
ହଉ ମୁଁ
ସେମିତି
ସେ ଡାକିଲେଣି ମୁଁ ଯାଉଛି ଆଉ ଫୋନ୍ କରିବି ନହେଲେ ଆଉ।
ହଉ ତାହେଲେ ଆସିଲା ବେଳେ ମୋତେ ତାଙ୍କୁ କହିଦେବେ ସେ ଯେତେବେଳେ ଆସେ ଇଚ୍ଛା ହେବ
ତାଙ୍କୁ କହିଦେବି ଫୋନ୍ ଗୋଟେ ରଖିଦେବି ଆଉ।
ହଉ
ହଉ
ତାଙ୍କୁ କହିଦେବେ ସେ ନେଇ ଆସିବେ ଆଉ।
ହଁ
ହଉ ସାର୍ ଠିକ୍ ଅଛି। ନା ଏଇଟା ଆମର ସେଟିଂଟା ସେମିତି ହେଇଛି ତ ଓଡ଼ିଆ ବୁଝିପାରିବନି ଇଂଲିଶଟା ବୁଝିପାରିବ। ହଉ start. The sparingly soluble salt is the sparingly soluble salt is the salt that is slightly soluble in water. That is slightly soluble in water. Sparingly soluble salt is the salt that is slightly soluble in water. That means the salt which is slightly soluble in water is called as the sparingly soluble salt. Example: silver chloride is a sparingly soluble salt. It is slightly soluble in water. Barium sulfate, it is also slightly soluble. Lead sulfate, it is also slightly soluble in water. So these salts are slightly soluble in water. So the solubility of these salts, the solubility of these salts cannot be determined by any chemical method. So the solubility of these salts cannot be determined by any chemical method, but the solubility of these salts can be determined using conductivity measurement. Using conductivity measurements. So the soluble salt can be determined using conductivity measurement, but any other method it cannot be determined. By any chemical methods it cannot be determined, but the conductivity measurements is the only one method in which the solubility of the salts of a sparingly soluble salt only. Sparingly soluble salt can be determined by conductivity measurements. Let us consider how you determine. You can know that. Let us consider to find out the solubility Let us consider to find out the solubility of the sparingly soluble salt of the sparingly soluble salt silver chloride. Let us consider to find out the solubility of sparingly soluble silver chloride at 25 degrees centigrade. At 25 degrees centigrade, I want to find out the solubility of a sparingly soluble salt silver chloride at 25 degrees centigrade. The solution of silver chloride is boiled. Then how you determine the procedure is that the solution, the procedure is that the solution of silver chloride is boiled. When it is boiled, more silver chloride is soluble, followed by cooling at 25 degree, followed by cooling to 25 degree centigrade, The conductancy of the solution is measured. The conductancy of the solution is measured using conductivity bridge. Then this is the conductancy of the solution. That means silver chloride solution conductancy is measured using conductivity bridge. The conductancy of the water is also determined. The conductancy of water is also determined at 25 degrees centigrade. The water means the water means which water? The water in which silver chloride solution is prepared. The conductancy of the water is determined at 25 degrees centigrade, and conductancy of the solution is also determined at 25 degrees centigrade. The cell constant of the conductivity cell is also determined. The cell constant means L by A, length separation between the anode and cathode, and area of one of the electrode. Both electrodes should have same area. This cell constant L by A is also determined. It is a constant. So the solubility of silver chloride can be determined as follows. The solubility of silver chloride can be determined as follows. The solubility of silver chloride can be determined as follows. How? Now let the conductancy of the water, let the conductancy of water at 25 degrees centigrade is C1. Conductancy. Water means in which silver chloride solution is prepared. Let the conductancy of silver chloride solution. Silver chloride solution means when you add silver chloride in water, then boil it followed by cooling to 25 degrees centigrade. At 25 degrees centigrade is C2. Okay, then the conductancy of silver chloride is silver chloride solution. That means if a beaker is there, water is there. First you determine conductancy of the water. Suppose conductancy of water is C1. Then you add silver chloride on it. Silver chloride you add. Then you boil it. Then cool it to 25 degree centigrade. Then in the solution you find out the conductancy C2. Now when you subtract solution minus water, that means only water is C1. Water plus silver chloride solution is C2. When you subtract this one minus this one, we get silver chloride. So the conductancy of silver chloride, that means water plus silver chloride minus water is equal to means C2 minus C1. That means water cancel. So the conductancy of silver chloride, is C2 minus C1. Conductancy reciprocal of resistance. Resistance unit is ohm. It is mho. Mho or ohm inverse. This is the conductancy means mho inverse. Unit you have to write mho inverse, mho inverse, mho inverse. Sorry, ohm. It's ohm inverse, ohm inverse, ohm inverse, ohm inverse. Ohm inverse is also called as mho. Okay, just reverse of it. That means you can write in this way, mho. Mho means in this way. If you write mho, then in this way. Or reverse of ohm. The conductance of silver chloride is C2 minus C1 ohm inverse. Let the cell constant of the conductivity cell, let the cell constant of conductivity cell is x. X is L by A. L by A means length by area of centimeter square. That means centimeter inverse. L by A, cell constant is L by A. L is centimeter, area is centimeter square by meter square. We get meter inverse or centimeter inverse. Okay, x centimeter inverse is the cell constant. And we know from the formula that resistance R is equal to rho L by A, which is equal to rho L by A is nothing but cell constant. We know that conductance is the reciprocal of resistance. So take 1 by R, then conductance is equal to 1 by R. We take 1 by R, then we get 1 by rho into 1 by cell constant. 1 by rho is nothing but conductivity kappa into 1 by cell constant. That means the conductivity is equal to conductance into cell constant. Conductance of what? Conductance of silver chloride, which is equal to this one, is equal to C2 minus C1 into cell constant is X. Cell constant is X. So this is equal to conductivity. Conductivity is equal to 3. Then our aim is to determine the solubility. the volume of the solution, the volume of solution containing S gram mole is 1000 cc. Thus the volume of the solution containing 1 gram mole is equal to 1000 by S cc. Then my molar conductance formula is lambda m is equal to conductivity into volume, that we know. V means volume containing 1 gram mole is equal to V. Then lambda m kappa is equal to this one, C2 minus C1 into X into volume is 1000 by S. Then 1000 by AS is the volume. Then S is the solubility. Then S is equal to C2 minus C1 into X is equal to into 1000 by molar conductance. This is called as the solubility, or you can write solubility is equal to specific conductance by conductivity into 1000 by lambda m molar conductance. This is the solubility. Or you can put the another formula. It belongs, because solubility, always remember, solubility is always expressed in terms of molarity, capital M. If you write small m, one found that molarity. So in terms of molarity only it can be expressed. You can also determine the volume from another method. The very easy method, that one, that was the molarity. Molarity is equal to weight of solute divided by molecular mass into 1000 by volume in cc. Weight of solute molecular mass is nothing but mole is equal to 1000 by volume in cc. The volume is equal to 1000 by m. In this way also you can find out the value. Okay, volume is equal to 1000 by S, number of mole of the solute. Okay, that means 1000 V you take to that side. V is equal to number of mole into 1000 by molarity. Here molarity, here hela mole, number of mole, here molarity. When it comes, it becomes nothing but 1000 by S. S means solubility. S means solubility. So solubility can be expressed always in terms of molarity. So this is how the solubility of a sparingly soluble salt can be determined. I have to end here. ओके बाहर बुलबनी सब पढ़ापढ़ी कर काली फास्ट इयर गोटे पिला तुम्हें चिन्ह न से पिला गोटे बाघ धरी पलैला से पढ़ु नाला टीवी देखुला तेणु से बहुत रिक्वेस्ट कर छाड़ी गला ना से खाई था सबू गाँव में 3 4 5 6 7 बाघ अच्छा से खाई ना छेली भोक लगुच तेणु से तुम यदि न पढ़ से तुम घरे पशि नहीं पलैबे तुमको आ छाड़े फास्ट इयर पिलाटा को नहीं पलैला तेणु छाड़ी गला पाठ पढ़िए बोली कहला भूल मागिला किंतु आउ से छाड़बनी ତେଣୁ ସେ ଭୁଲ କରିବନି, କେବଳ ପଢ଼ିବ ହିଁ ପଢ଼ିବ, ଟିଭି ବି ଦେଖିବନି। ଓକେ, ଆଇ ଆମ୍ ଏଣ୍ଡିଂ ହିଅର୍।